All right, this video is on slope. So before we get started, I want you to go ahead and practice graphing this, okay? So go ahead and pause it, fill in a table, plot some points, and then hit play to check your work. All right, so this one has 4 points. If you only did 3, that's fine. So you'd have negative 1, 4, you'd have 0, 1, 1, negative 2, 2, negative 5. All right, so then you know our points. So we got negative 1, 4 is the first one, right? 0, 1 is my next point. 1, negative 2 is the next one. And 2, negative 5 is my last point. All right, so we're talking about slope today. So slope is talking about how steep a line is, okay? And in which direction is it going? So this line's pretty steep, and it's going down, okay? So what I mean by down is, because you could say also that this is going up, is looking from left to right. So the furthest point left is over here. And as it moves right, it's going down, okay? So as it goes down, this means this slope is negative, okay? And we're going to talk some more about that. So it has a lot to do with what you might think of as ski slopes, right? How steep is something, okay? So the slope is describing the steepness, where, for example, this is not very steep, but this is, okay? So just looking at it, you can tell a lot. So like I said, going from left to right, so the furthest point left, as it moves right, it tells you whether it's positive or negative, the slope. So this would have a positive slope, okay? So this slope would be positive, and it would probably be bigger than 1. It's a pretty steep slope. This one, also positive, going up from left to right. Make sure you're reading it from left to right, because obviously if you go the other direction, it's going down. But left to right, it's going up. It's a positive slope, but not very steep. This one is going down. So we're going to have a negative slope here. But again, not very steep, not going to be a very big slope. This time we got negative again, but much bigger slope. This is going to be a larger number, definitely bigger than 1, this slope. All right, this is our first one where we see where just looking at it, you can know the value of the slope, the number of the slope. This slope would equal 0, okay? Because it's not sloping at all. Kind of makes sense, right? It's a straight, flat line. There's no incline or decline. So this slope, if it's a straight horizontal line, is 0. Remember that. This is our other example where I instantly know the value of my slope. This is a very steep slope, so much that it's not really even sloping, right? It's just going straight up and down. So this slope is what's called undefined, okay? So if it's a straight vertical line, it's undefined. An easy way to remember that is if you were skiing on this, you would probably be undefined at the bottom of this slope because you would be dead because it is so steep, okay? So those are the two where we know just by looking at them what their values are. We got the slope of 0 and an undefined slope. All right, the other ones, you're going to have to do some math to actually get what number their slope would equal. You know whether it's positive or negative just by looking, but now let's talk about how we can figure out the actual number value of the slope, okay? So slope is a ratio, and it describes how steep a line is, okay? And the ratios compare two things. This ratio compares the rise to the run. Now, rise means how much it's going up or down vertically. Run means how much is it going horizontally, okay? Other times you'll see that described as the change in y. Remember, y is the vertical value, okay? So how much it's going up or down vertically compared to the change in x, the run, okay? How much is it changing horizontally, okay? So we got rise over run, or change in y over change in x. Both mean the same thing. It's just saying how much is it going up or down compared to how much is it going over, okay? There's a variable we use for this slope, and it's very confusing, and I don't know why they choose that letter other than maybe there's some Greek or Latin background there. You might want to Google it, but the letter is M for slope. I remember it because of mountains. That might be an easy way for you to remember it too, okay? So the formula for slope, for M, is y2 minus y1 over x2 minus x1. Very confusing when you first see it, so let me explain it a little bit and hopefully clarify some, but it'll take practice to really understand it. Those little numbers are not exponents. Let me repeat, those little numbers are not exponents, okay? They're saying there's 2 different y's and there's 2 different x's. So to find a slope, you need 2 points, okay? 2 points on the same line, because remember, you're finding slope of a line. So you have your 2 points. Point 1 is x1 and y1. Point 2 is x2 and y2. Doesn't really matter which point is which, okay? And all you do is you're finding the difference between the two y's to see how much the y changed, and then the difference between the two x's to see how much the x's changed, okay? And that is slope. Now, if you're confused right now about what all this means, don't worry, you are not alone, okay? We're going to do some practice until you understand it. All right, so let's try to figure some of this out. So there's 2 ways to do slope, okay? Especially if you have a graph like this. So we have our 2 points that are marked on our line. So here's our line. They marked out 2 of the points on it for us, right? There's other points on there. But our first point is, what is that? -4, 7. And then this one is -2, 2. So those are the 2 points they've marked for us. So your first method is to just count how much is it changing. How much is the rise changing? How much did the y change? So going from this point right here, it went down 1, 2, 3, 4, 5 places. It went down 5. So I marked that as a -5 for my rise. And the run, so going over, it went over 1, 2 spaces. So it went over 2. So my slope, which is rise over run for this line, is -5, 2. And notice for slope, it's a consistent pattern. So you could use it to find other points. Look, if I go from this point, if I go down 5 more, 1, 2, 3, 4, 5, and over 2 more, 1, 2, look, I'm on the line again. That's another point. You can keep going, 3, 4, 5, 1, 2, look, there's another point, okay? So it's a consistent pattern. So that's why it doesn't matter which 2 points you pick, your slope will always be the same. So that's method 1, is to just count. If you have it graphed already, it's a pretty easy method to use. Let me show you method 2 is using the formula, okay? And this is more helpful when you only have the points to work with. So I need to get my 2 y values, 7 and 2, and subtract them, over my 2 x values, which in this case are -4 and -2, and subtract them. Now, the only thing that matters about the order is that if you start with this point, you need to start with this point for the x's too, right? You can't go 7 minus 2 and then go -2 minus -4. That doesn't work, okay? You have to be consistent in your ordering, okay? Otherwise, the order doesn't really matter. You could have started with this point down here. All right, so I do my subtraction to get 5 over. Remember these minus and negative, it turns into a giant plus. So that ends up being a -2. So look, 5 over -2. These two are the same thing. They represent the same number. -5 over 2 or 5 over -2, same thing. So that's my slope. 2 different ways to find it. So let's practice finding slope now using these 2 methods. So go ahead and use the formula method on this one because you're just given the points. You don't have a graph of it, so it's not easy to count, okay? So go ahead and pause it, try the formula out on your own, and then hit play to check your work. All right, so we need the y values, which are 3 and -4. Notice I started with the first point. It doesn't really matter which one you start with, as long as you're consistent. So if I started with the first point there, I need to start with the first point down in the denominator as well. And then, so my addition there, because minus and negative is plus, and -5. So 7 over -5. If you had done it the flip-flop way, you should have gotten the same answer. It would have been -4 minus 3 if you started with that second point, and 10 minus 5. So that would have been -7 over 5. Again, same thing. Remember, it doesn't matter where the negative goes. It ends up equaling the same thing. All right, go ahead, and I would recommend trying both methods on this one, both the counting and using the formula. Make sure you get the same answer for both. All right, so on this one, clearly my slope's negative, it's going down. If I was gonna count, I would start from the first one, I go down 1, 2, 3, 4, 5, 6. So my rise is -6. My run, it goes from here, goes 1, 2, 3 over. So -6 over 3 simplifies to -2 over 1, but I'm just going to write -2 as my slope. If I were to use the formula, this point is 3, 6, and this is 6, 0. I would have had 6 minus 0 over 3 minus 6. So I get 6 over -3. Again, simplifies to -2. So no matter which method you use, you should have gotten -2 as your answer. Go ahead and try this one on your own, then hit play to check that you're getting the correct slope. All right, so this one I would use the formula. So remember, make sure you put y's on top. Don't put the x's on top. That's a common mistake people make. So 2 minus -1 is 2 plus 1. 6 minus -1 is 6 plus 1. So 3/7 is the answer you should have got, okay? If you had flip-flopped it the other way, you would have gotten -3 over -7. And remember, those two negatives cancel out, and it ends up equaling 3/7 that way as well, okay? So it doesn't matter which order you put your points in. All right, so slope is really helpful for graphing, okay? If you are given a point and a slope that a line goes through, you can graph it, okay? Your point is your starting point. So 2, 2 is my starting point. And your slope is like a GPS, it's directions. Remember, it's rise over run, okay? It's a fraction. So -4 is a fraction, is -4 over 1. Remember that any whole number is over 1. And so it's telling me it's rising -4, so basically it's going down 4. 1, 2, 3, 4. And over 1 to get to the next point. Down 1, 2, 3, 4, and over 1. And there's another point. And you can keep going. You can go on forever, but you really, 2 is probably plenty. And connect the dots, and that's your line. Okay? So as long as you have a starting point and a slope, the starting point is clearly where you start, and the slope is directions to get to each of those next points. It tells you how much to go down, how much to go over, and it gets you to that next point. So go ahead and try graphing using this starting point and this slope, and then hit play to check your work. All right, so I start with my starting point at 0, 1, and my slope this time is 2, 3. So remember, it's rise over run. So I'm going up 2 and then over 3, and that's a point. Up 2 and then over 3, and that's a point. 2 over 3, and that's a point. I'm clearly doing more than you really need to, but just to kind of emphasize my point of how you find all of those, okay? It's a consistent pattern, so your line should look like that. All right, go ahead and pause it, try this one on your own, and then hit play to see how you're doing. So you have your starting point of 3, 4. And this time you have a slope of 0. Remember what I said in the earlier slides? Slope of 0 is just a horizontal flat line. It doesn't go up or down at all. So you could just kind of draw little points all along there, but really you just draw the straight line. So as soon as you know it has a slope of 0, you know that's a horizontal flat line. All right, go ahead and try this one on your own, then hit play to check your work. So starting point, -8, -1. Make sure you get the right starting point. Obviously, if you start in the wrong place, it's going to completely mess you up. And slope of 2, so remember you can make that a fraction by making it 2 over 1. So that means it's rising 2, going over 1, 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 etc., etc., etc. These little marks that I'm making, these little things, you don't have to draw those. I'm drawing those so you can see what I'm doing, since you can't see my hand and where it's marking. The only points you should be actually marking are the ones that are going to connect your line, right? Those are the actual points on the line. All right, go ahead and hit pause, try this on your own, then hit play, check your work. All right, so we got -2, 8. So we're starting up there. Make sure you have the right starting point. Slope of -1 over 5. So -1, we go down 1, and then over 1, 2, 3, 4, 5. Down 1, 1, 2, 3, 4, 5. So my line's looking like this, not super steep. All right, last one. If we have a point at -3, -2, and the slope is undefined. So first graph your point, -3, -2. And remember what I said about undefined slopes from the earlier slides. That is that straight vertical line. So that is an undefined slope, straight vertical line. You don't really